Okay, it's time to switch things up a little. What if Earth suddenly shrunk to be the size of the moon, and the moon expanded to be the size of Earth? How would you be able to fly on this tiny Earth? Why would you never see the moon again? And could humans on Earth survive this catastrophic switch? This is What If, and here's what would happen if the moon and Earth switched sizes. Okay, quick brain fact. Did you know that curiosity is one of the only emotions that actually rewires your brain in real time? The moment you lean in to understand something, like you are right now, your neurons start building new pathways. When you watch curiosity-fueled content like this, your brain treats it like active learning, decoding and making sense of new ideas just like it does when you solve a puzzle. So, watching our shows is literally good for your brain. Well, that's why we launched the Popular Science Fast channel, where you can stream all our shows 24/7. Tune in any time of day and you'll find mind-bending science from us and from some of the world's leading creators, including NASA's spaceflight, Hacksmith, and Complexly. Plus, live rocket launches, documentaries, and deep dive specials. It's basically a non-stop feed of curiosity, always on, always learning. We're currently available on 10 different platforms, including Vizio, Roku, and Plex, but we're just getting started. We're reaching tens of millions of homes and streaming devices all over the globe, and that audience keeps growing every month. And the channel just keeps evolving. We're adding brand new series and specials monthly, from breakthroughs in tech to space exploration coverage you can watch live. It's a front row seat to the new space race, alongside a 150-year-old legacy of science storytelling, now being brought to streaming for the first time. So, if you ever finish one of these streams and still want more, well, you don't have to wait. You can jump straight into Popular Science and keep that curiosity going. It's there 24/7, ready whenever your brain wants its next aha moment. Okay, before we see what happens if we switch things around, here's the baseline. If Earth shrunk, everything on Earth would become smaller, but in proportion to each other. Earth would have the same land, continents, mountains, oceans, crust, and iron core, only shrunk down to the size of the moon. And just to keep it simple, we'll call this new Earth Little Earth, and the larger moon would be the big moon. Little Earth would be smaller, but humans, animals, and plants would stay the same size. So buckle up, it's about to get very crowded. Our regular-sized Earth is about 4 times larger than the moon, and it's 80 times heavier. But not today. Today, these celestial bodies are in for a big switch-up. Little Earth would now become a moon of the big moon, and it would start to orbit around it. But I'll get back to this a little later. First, let's talk about gravity. It would be massively different. For any celestial body, the force of gravity depends on both mass and radius. Little Earth's radius would be around 1/4 of what it used to be, but its mass would only be 2% of a regular Earth. This is a massive change that would definitely make your life harder, or lighter. I mean, on this little Earth, you would feel lighter because gravity would only be 27% of Earth's original gravity. If you were 70 kilograms on regular Earth, well, now you'd only weigh about 19 kilograms. That's good news for me because I'm really bad at working out and dieting. With this new low gravity, moving around would be way more fun. You'd feel like Neil Armstrong bouncing around on the moon, only you'd still be on Earth and you don't need a spacesuit. Places that used to be far away would suddenly become so much closer. New York to Paris, well, it's no longer 6,000 kilometers and 7 hours away. Now it'd just be 1,500 kilometers and less than 2 hours to fly. It would take less fuel to get there, but also less fuel for aircraft to launch into the sky thanks to low gravity. Now, it's great to weigh less, float around, and get to Paris in no time at all, but I'm afraid there would be some bad news. We humans evolved on a planet with much higher gravity, so we're not adapted to living in a low-gravity environment. Over the course of just 6 months out in space, astronauts can lose 13% of their muscle mass. Now, being in low gravity wouldn't be as bad as being in zero gravity, but your body still wouldn't like it. Your spine would break down and lengthen, and you'd have constant back pain. Your muscles would weaken, and with less gravity, your body's fluids would move up the body more easily, resulting in what some scientists call a puffy-faced bird leg syndrome. Yeah, it's exactly what it sounds. You'd have tiny legs and a swollen face, and your eyes would get damaged. Meanwhile, the big moon would now be as wide as Earth and would weigh about 2/3 as much as the original Earth. Well, guess what? Its gravity would increase by a lot, too. Right now, the moon's gravitational pull is only 1.62 meters per second squared, but with this new size, its gravitational pull would become 5.96 meters per second squared. That's like 60% of regular Earth's gravitational pull. Just because there's no life on the moon that we know of, it doesn't mean it wouldn't be a big deal, because the gravitational pull from the new big moon would create havoc with something else: little Earth's tides. On the regular-sized Earth, the tides are 1 meter high, give or take, but if the moon suddenly became much heavier, it would pull more violently on the surface of Earth. What used to be a tide would now be a tsunami. Say goodbye to coastal cities like New York and Venice. They'd be flooded and wiped out. Millions of people would die. And that's only the beginning. The gravitational force from Big Moon would pull so hard on Little Earth that it would deform the Earth's surface. Cue massive earthquakes and extreme volcanoes. This is because gravity would be acting on Little Earth's molten core, similar to how Jupiter causes volcanoes to erupt on its moon, Io. Now, remember I said you wouldn't need a spacesuit on this new Little Earth? Yeah, forget that. You definitely need one. You're able to survive without one on Earth because our planet has a wonderful, thick atmosphere. It has oxygen for you to breathe, and it protects you from the sun's harmful radiation. But on the new Little Earth, well, we're going to lose our atmosphere, and this would happen really quickly for 2 reasons. The first and most immediate one is gravity. Regular Earth's gravitational pull is strong enough to hold the atmosphere in place, but with a sudden drop in gravity, the atmosphere would start to drift off into space. Big Moon might actually pick up some of these gases, and who knows, maybe this gray rock would become the newest, most livable place in the solar system. Even if Little Earth held on to a little bit of its atmosphere, there's a second problem that would hack away at it over time. With its smaller size, Little Earth would cool more rapidly. Over time, it would lose all the heat from its molten core. That's what happened to the moon when it formed 4.5 billion years ago. Back then, it was molten too, like Earth's. Maybe you're thinking, what's the big deal with losing our hot molten core? I'll tell you. The outer part of the molten core is what gives our planet its magnetic field. Earth's magnetosphere also helps to hold the atmosphere in place. Without a magnetosphere, solar winds would strip away the atmosphere. Of course, losing all of Little Earth's atmosphere would mean you wouldn't be able to breathe, and as the atmosphere is slipping away, the temperatures would become extreme, like a desert. During the day, it would get extremely hot, and then at night, the temperatures would plummet. Little Earth would likely hold on to its ice at the poles, just like Mars did, but all the liquid water from our oceans and lakes would boil away. And that would pretty much be the end of life on Little Earth. Without an atmosphere, you'd be exposed to so much radiation from the sun that even if you managed to survive this far, you'd be suffering cancer and cataracts. Your nervous system would get fried too. While Little Earth would lose its atmosphere pretty quickly, our magnetic field would take longer to disappear. It took about 200 million years for the moon to lose its once existent magnetic field. Over those millions of years, there'd be another major change on this new Little Earth, and I mean major. Our Earth would stop being a planet. To explain this, I need to roll back a bit. The moon is tidally locked to Earth. By that, I mean the moon takes the same amount of time to make one rotation on its axis as it takes to do one revolution around Earth. Because of that, one side of the moon is always facing our planet. In our new scenario, after millions of years, little Earth would eventually become tidally locked to the big moon. At first, the big moon would make little Earth slow down, and after millions of years, this Earth-Moon system would reach equilibrium. Only now, little Earth would orbit the big moon, and we would always face this big moon with one side. Well, that would make Big Moon a planet, and little Earth, well, we'd be Big Moon's moon. With tidal locking, though, one half of our planet would never see the big moon in the sky. Are you ready for another mind-blowing change? Well, the length of a day on little Earth would no longer be 24 hours. Could last as long as a month. You'd have half a month of darkness, followed by half a month of daylight. On the bright side, all-night raves and pajama parties would last a really long time. Oh wait, at this point, you'd be long gone thanks to the extreme temperatures, volcanoes, earthquakes, and even more extreme radiation exposure. But what about Big Moon? Well, since it was already tidally locked to Earth, that tidal locking would stay in place even after the switch. Now both would be tidally locked to each other. Okay, you know what? We're going to stay positive and let you survive all the catastrophic events on little Earth. Somehow. You'd still be struggling to breathe in a thinning atmosphere. Your body would be taking a beating from the low gravity, temperature extremes, radiation, earthquakes, volcanoes, tsunamis, you name it. Your life on this little Earth would be miserable. But on the positive side, the big moon would look awesome up there in the night sky. It'd glow 4 times as bright as before, and you'd get to see total solar eclipses much more often. With all the problems on little Earth, Big Moon would start looking like a much more attractive place to be, at least in a couple of ways. For one, it would have more gravity than little Earth. Plus, it's sitting in the Goldilocks zone in terms of distance from the sun, so if we moved there, we'd get the same amount of solar energy as we're used to. The two big problems? Big Moon still lacks an atmosphere, and there's no liquid water. So if humanity, or whatever was left of it, wanted to settle on the big moon, well, we'd have to build an atmosphere for it. One way we could do this is to break the big moon's crust to release gases from underneath it. And the fun part, we'd do it with nukes. With the new higher gravity, the big moon would have a better chance of holding on to this new atmosphere. Then, with a basic atmosphere in place, our next step would be to get some water out of the water ice at the moon's poles. The regular-sized moon has about 6.6 billion tons of water ice at the poles. But of course, with the new big moon's size, there would be several times more water ice than before. After freeing up the water, plants could be introduced to produce more gases and create some oxygen. The first steps toward a moon base would be in place. But how would we transport supplies to Big Moon from little Earth? Well, one bit of good news is that with little Earth's lower gravity, it'll take a lot less fuel to launch a spaceship to the new moon. We could use Starship technology to make a moonship to establish a settlement on the moon. So maybe humans will somehow find a way to survive. We've survived catastrophes before, and hopefully we will again.
Some of the planets in our solar system are gigantic, but what if they got even bigger? Let's go up the planetary size chart and see what kind of chaos doubling the size of every planet would make. What would it be like to live on a super Earth? How big would Jupiter need to get to become a star? And would Pluto finally regain its planetary status? This is What If, and here's what would happen if all the planets doubled in size. Doubling the radius of every planet in the solar system would make each of them 8 times more massive, but You wouldn't need to worry about our solar system's great ball of fire getting bigger and hotter. For the sake of this experiment, let's keep the sun the same size it already is. But could the gravitational pull of a super Jupiter kickstart a chain of events that would result in the destruction of the solar system? Mercury. At its current size, the rocky planet closest to the Sun is only slightly larger than our Moon. Doubling it in size would make it nearly half as massive as Earth. And despite the fact that Mercury stopped being volcanically active 3.5 billion years ago, expanding its interior would mean all that internal energy would need to escape somewhere. So there could be some more explosive volcanic eruptions in Mercury's future. Venus. Venus is very similar in size to Earth, but one of its many differences is that its atmosphere is so thick that the surface pressure is 95 times stronger than our own. Venus's increased gravity would pull the atmosphere even closer to its surface. This could result in the atmosphere becoming so dense that walking through it would feel more like walking through water. Except you'd really be walking through incredibly thick carbon dioxide. Earth. If Earth expanded to twice its size, the first big change you'd notice is that you'd feel a lot heavier. Within seconds, you'd go from your 75 kilogram weight to feeling like you were 150 kilograms. That would be because the force of gravity pulling on you would be twice as strong. You better hit the gym to strengthen up fast because this wouldn't be easy on your body. Your heart would need to work twice as hard to pump blood around, and pressure would build up on your joints. Jumping, flying, or sending rockets into space could become a thing of the past. You'd need much more fuel, power, and money to leave Earth's surface and travel through its even thicker atmosphere. Mars. Now, if the red planet ballooned to twice its size, there's a chance you would barely recognize it. What was once a dry, desolate place could eventually transform into a more Earth-like planet with oceans, rivers, and a thick atmosphere. Mars lost its magnetic field and then its atmosphere, likely because of chemical changes inside its core. But if the Martian core got bigger and hotter, it could restart the magnetic field. And that, in turn, would protect Mars from solar winds and give it a chance at kickstarting life. Jupiter. Doubled in size, Jupiter would continue to be an intimidatingly huge planet. It would stay 318 times larger than Earth and 2.5 times more massive than all the other planets combined. And the impact of this would be so huge that it would likely shift the actual center of our solar system. You see, the planets in our solar system don't exactly revolve around the sun. No, they orbit the common center of mass, or barycenter. And thanks to Jupiter's normal size, this barycenter is actually 48,000 kilometers away from the center of the sun. But doubled up, this point in space would move even further away from the sun. You'd see material from the asteroid belt being pulled toward Jupiter or further out into the solar system. But even this big, Jupiter wouldn't be massive enough to become a full-blown star. To do that, it would need to increase to 85 times its current mass. Though it wouldn't be far off from star status. At 13 times its original mass, Jupiter could become a brown dwarf star. Saturn. With a bigger Saturn, you could kiss its beautiful rings goodbye, the monumental increase in the planet's surface gravity would upset the balance of the ring materials, as well as Saturn's 5 small moons. They'd start falling towards its surface at a higher rate. Saturn is already slowly losing its rings. Every 30 minutes, material containing enough water to fill an Olympic-sized swimming pool falls down to the planet. Uranus. Now, beyond its added heft, not all that much would change for the ice giant Uranus way out on the edges of the solar system. It would continue holding the record for the stinkiest planet. If doubling Uranus's size would mean doubling the amount of hydrogen sulfide in its upper atmosphere, this stinker might spread an even stronger stench of rotten eggs. Ugh, I wouldn't want to go near this planet. Neptune. Neptune's fate wouldn't be too different from its giant frozen neighbor, except Neptune's increased gravitational pull could eventually lead to the disappearance of some or all of the billions of icy objects located outside its orbit. Neptune has already swallowed the equivalent of 7 to 10 times the mass of Earth in material from the Kuiper Belt. Pluto. If Pluto doubled in size, well, it could be back on track to regain its official status as a planet. If its added mass and gravity could manage to pull away debris from its surrounding neighborhood, it might just be able to rejoin the rest of the family. Alright, so it's safe to say that all the planets doubling in size wouldn't exactly bring about a cataclysmic end of the solar system. It would, however, cause a little chaos. Ever feel like the Earth is just too small? Well, let's make it bigger. Much, much bigger. Welcome to a new Earth that is just as big as Jupiter. In what ways would Earth change? What things would stay the same? And how would this affect you? This is What If, and here's what would happen if Earth were the size of Jupiter. A super-Earth is a planet with a mass up to 10 times bigger than the Earth. But don't let the name deceive you. These super-Earths aren't anything like the Earth you know. These planets could be rocky or covered entirely in ice. They could even be gaseous like Neptune. But if you want to make the Earth as big as Jupiter, get ready to make a super, super, super Earth. While Earth, as it exists now, is much smaller than Jupiter, it is a pretty dense rock compared to the gas giant. Our new planet would be massive, about 1,300 times bigger than Earth today. And that's not the only thing that would be different. Jupiter has a radius about 11 times that of Earth. Get used to a little more gravity when you walk around. Yeah, 11 times more. So, if Earth was this huge, how soon would the gravity completely crush your body? This change in size would have enormous implications for you and all other life on Earth. The first thing you'd notice with 11 times the surface gravity is that you would weigh more. And there's not much a diet plan could do to change that. You'd be 11 times heavier than you are now. So, if you currently weigh 70 kilograms, well, get ready to start lugging a hefty 770 kilograms around. Would you even be strong enough to carry your own weight? Well, you'd be heavier than the world deadlifting record of 501 kilograms held by Game of Thrones star Hafthor Bjornsson. So, yeah, good luck. But if you were a couch potato, this could be good news. Getting up from the couch wouldn't be an option. You wouldn't have the muscle strength. Even breathing would be a near impossible task. Scientists have concluded that the maximum gravitational field that humans could adapt to is about 5 times the gravity of Earth. Well, now double that, and that would be your new normal. And you wouldn't be the only one feeling heavier. All that gravity would result in increased atmospheric pressure. Yeah, you'd feel the air pressing down on you. This would have severe environmental impacts. Water molecules would need more energy to escape their liquid form. That means the boiling temperature of water would be much higher than 100 degrees. And the freezing point would now be way below 0 degrees. It would be harder for you to make ice. And even the large chunks of ice, like icebergs, could melt away. And there would be disruptions beyond life on the surface of Earth. Introducing a massive planet into the solar system would create some serious instabilities. Our moon would experience extreme changes in tidal forces. This gravity could be strong enough to pull the moon apart into teeny tiny pieces. The only remnant you'd have left would be a new ring of debris forming around Earth. The sun would still be 250 times more massive than our new Earth, so Earth wouldn't steal any planets away, but our super-Earth could have some effect on their orbit, just as Venus and Jupiter impact our orbit and climate today. The Earth would affect the orbits of other celestial bodies like asteroids. Our gravitational pull could be strong enough to eject these objects from the asteroid belt and set them on a collision path with you. And that would be bad news. Remember, you wouldn't be able to move a muscle to escape. So maybe it's better if Earth stays the same size as it is now.
Catastrophic planet-wide tides flood cities. Pitch black nights. An ice age more powerful than Earth has ever seen. And tungsten-shaded evening skies. This is what would happen if we swapped our moon with other moons in the solar system. And spoiler alert, you're not surviving most of these. Let's start this epic show with the truly titanic moon, Titan. You are used to our regular old moon. You're used to its size, the look of its surface, covered in gray lunar regolith. What you're not used to seeing is this up in the sky. Yeah, that's Titan. This moon of Saturn is a behemoth. It's the second largest moon in the entire solar system. It's even bigger than the smallest planet, Mercury. Unlike Mercury, it's icy cold. We're talking minus 180 degrees Celsius. That's minus 290 degrees Fahrenheit. Its surface is covered with rivers, lakes, and seas, just like Earth, except that these bodies of liquid are not made of water. That's methane, and you shouldn't swim in it. You'd see a big change on Earth if we swapped our moon with Titan. Instead of that silvery white light, our nights would take on a golden orange twilight, and our new Titanic moon would loom larger in the sky, as it's about 1.5 times the size of the old moon's diameter. But Titan is a very special moon. It has a thick, nitrogen-rich atmosphere that stretches almost 600 kilometers into space. So our new moon would appear like a giant, fuzzy orange orb. So far, not a big deal. Unless you hate orange, or rhyming things with orange. But things are about to get terrible for you. Titan is 80% more massive than our moon, so its gravity would pull harder on Earth's oceans. Here on Earth, that would be a very big deal. High tides would be far higher, and low tides, obviously much lower. Now, we can deal with lower tides, but high tides, would flood our coastal cities twice a day, every day. There would be more erosion and turbulence on every coast. This would be the only time you'd ever hope you don't own beachfront property, because by now, it'd be gone. Things wouldn't be the same for Titan either. After moving all the way from Saturn's orbit to ours, this moon would receive far more solar energy from the sun. It would start to heat up. For all the methane on its surface, it would be game over. Titan's methane lakes would eventually evaporate. The icy crust would begin to melt, and soon it would reveal the watery subsurface ocean that lies beneath. And that could be a fascinating moment. If any life exists beneath the icy surface in the ocean below, we'd land on Titan's surface and explore it. Now, this ocean could be hundreds of kilometers deep, but that just means there's a lot more to explore and maybe a lot more to find. The bad news is Titan has low gravity. That means it couldn't hold on to all that liquid and atmosphere forever. Over millions of years, it would bleed gases and water out into space, slowly drying out. Yeah, this moon would become just as sad and lifeless as our own moon. Bye-bye, hazy methane orb in the sky. Now, if you thought Titan was big, well, this moon is gargantuan. The only moon in the solar system bigger than Titan is Jupiter's Ganymede. It's also the only moon in the solar system that has its own magnetic field. It's about 1.5 times larger than our moon, so by night it would look about the same size as Titan, only instead of an orangish nighttime, Ganymede would shine extremely bright. Yeah, Ganymede is covered in ice, and that icy surface reflects far more sunlight than our moon does. To you on Earth, this rock would now look much, much brighter. That would be bad for astronomers because they wouldn't be able to see so far into space with this new moon overwhelming the sky. And you might have to invest in some better curtains. Well, that's not that bad so far, but stay with me. I saved the most dramatic part for later. Ganymede is about twice as massive as our moon, and its stronger gravity would unleash worldwide megatides. Like with Titan, you'd see coastal flooding twice a day, wild erosion and wave activity, and some very destructive storms. Ganymede's presence would be earth-shaking, literally. Its tidal pull on Earth's crust could trigger earthquakes and cause volcanic eruptions worldwide. The one upside, if you're around to see it, Ganymede would stabilize Earth a little. Specifically, it would stabilize the Earth's axial tilt. That would mean no more ice ages and a steady climate forever, so Ganymede itself would start to warm up. Now, you might think that the moon is chilly, but in full sun, it can reach temperatures of 125 degrees Celsius. It's 260 degrees Fahrenheit. Yeah, the moon can get hot. But Jupiter and Ganymede get roughly 1/30th of the sunlight that the moon does. And Ganymede is usually a chilly minus 112 degrees Celsius on its warmest days. It's been cold there for billions of years. As Ganymede is heating up, its immense 150 kilometer thick crust of ice would start to sublimate or even melt. This icy rock wouldn't be so icy anymore. It would now have oceans and water clouds. Beneath that crust lies an extremely deep saltwater ocean. Scientists think it's 100 kilometers or 60 miles deep. You know, in time, you'd go vacationing on Ganymede instead of Cancun. Now, Ganymede has its own magnetic field, and it also has auroras. Imagine traveling far north to see our own northern lights, and there in the background, Ganymede's auroras as well. Pretty cool. Ganymede might destroy everything you know on Earth, but it would also become a pretty inviting rock. If you survived all these earthly disasters, well, you could go live there. Okay, moving on to a hellscape of a moon, Io. Io is the third largest moon of Jupiter, famous for its hundreds of volcanoes blasting molten sulfur lava hundreds of kilometers into space. Io is the most volcanically active body in the solar system because it's subjected to a phenomenal gravitational push and pull between Jupiter and its hefty moons, Europa and Ganymede. The tidal forces cause extreme physical distortion and create intense heat, and that heat unleashes itself through endless volcanic activity. Volcanoes and molten lava lakes cover the surface of this virtual inferno, which would make for a pretty phenomenal show the moment we swapped it out for our comparably static moon. Our moon hasn't had volcanoes for millions of years. Io would be spectacular to watch from Earth. By night, it would shine 5 times brighter than our old moon, with a golden orange glow. You'd be able to see Io's volcanoes erupting with a simple telescope. But as hellish as Io might sound, it wouldn't be so bad a companion for Earth. You see, Io is quite similar in size and mass to our moon. You might see a slight increase in the tides, but nothing disastrous. And without Jupiter, Europa, and Ganymede constantly playing a gravitational tug-of-war with Io, the new moon would immediately stop being torn by the three-way stress that heated it mercilessly and caused all those volcanoes. Io would cool down, the volcanoes would go dormant, and our new moon would eventually turn cold and quiet, not unlike our current moon. So, what would happen if we swapped our moon with another famous moon of Jupiter? Next up, Europa. This is one of the most famous moons in history. Since Voyager flew past Jupiter and Europa in 1979, scientists have been intrigued by Europa's icy crust and the possibility of an ocean beneath it, which, of course, opens up the possibility for life. But Europa has even more surprises. Back in the 1990s, NASA's Galileo spacecraft picked up something odd when it was studying Jupiter's magnetic field. Right in the spot where Europa orbits, the field looked strangely distorted. Now, Europa doesn't actually have a magnetic field, so where was this disruption coming from? Scientists think this answer lies beneath its icy shell. Europa might have a vast underground ocean of salty water, and as Jupiter's magnetic field sweeps past, it stirs up the electrical currents in that ocean. These currents create a temporary magnetic effect, which is what Galileo detected. This ocean on Europa could be up to 150 kilometers, that's 100 miles deep. It's quite a bit for a moon. For comparison, the deepest depth of an Earth ocean is only 11 kilometers, 6.8 miles. So yeah, swapping our moon with Europa would affect you on Earth. For one, Europa's icy crust would reflect more than 5 times the light that our moon does. And it has a lower mass, so our tides would be weaker. Over millions of years, Europa would make Earth's axial tilt a little more unstable and cause some huge climate swings on our planet. But before Europa had a chance to destabilize Earth, you'd have a better look at it. Okay, now you wouldn't have to send a spacecraft nearly 3 billion kilometers, 1.8 billion miles, to study this moon. At just 385,000 kilometers, that's 238,855 miles from Earth, Europa would be just a 3-day trip away. NASA's planning to have people back on the moon by 2027, and that means we could have people walking on Europa in just a few years, studying its surface, searching for life. Now that is cool. Sure, in time, Europa's subsurface ocean would begin to freeze, but Jupiter wouldn't be around to exert the same kind of tidal squeezing it has for billions of years. And its surface would start to warm up, melting or sublimating its ice. Over time, Europa would go from a mysterious ocean world to a frozen, quiet moon. But in the meantime, maybe we'd find we're not the only ones out here. Okay, up next, another frozen moon, but one that doesn't play by the rules. Triton. Triton is a weird moon. It's the largest moon of Neptune, and it's the only sizable moon in our solar system to orbit in the opposite direction of its planet's rotation. The scientists call this a retrograde orbit. Now, if we swapped not just our moon, but also the direction it's going, that means our new moon, Triton, is going the wrong way. Triton is another one of these highly reflective icy moons that would light up the sky, but it's not nearly as massive as our moon, which means Earth's tides would drop dramatically. Instead of the moon being the primary driver of our twice-daily tides, the sun would take that role, and the sun only exerts about half of the tidal force that our moon does. Over millions of years, lacking a strong lunar anchor, Earth's axial tilt would wander more, leading to unpredictable shifts in climate and more extreme ice ages. But when it first shows up, Triton would put on a show. Bright, retrograde, and sporting ice volcanoes. That's right, outside of Earth and Io, Triton is one of the most volcanically active spots in the solar system. Except it's not spewing molten rock, it's venting cryomagma from cryovolcanoes, which is really just a fancy way of saying it's erupting ice up to 8 kilometers, 5 miles, into its atmosphere. So we'd have a front row seat every night to watch our moon blast cryomagma out into space. Out by Neptune, it's so cold that the ice on this distant moon is made of frozen nitrogen, water, and methane. Triton's surface is one of the coldest places in the solar system, reaching a frigid minus 235 degrees Celsius. That's minus 391 Fahrenheit. Now, being so much closer to the sun, its surface would quickly start to warm up, and all that frozen nitrogen would be vaporized, which could create a thick, hazy atmosphere, maybe even a comet-like tail. Over the centuries, Triton would slowly lose its icy shell, and if it has an ocean beneath it, that would begin to dissipate as well, eventually becoming a smaller, drier remnant of its former shining self. But in its early days, Triton would light up the night and put on quite the show, unlike our next moons, Phobos and Deimos. So far, we've mostly swapped our moon for huge or medium-sized moons, but our next-door neighbor Mars sports a pair of satellites that are tiny. Phobos and Deimos are officially moons, but they might just be asteroids that Mars caught in its gravity and they now orbit around the red planet. Phobos, the big sibling, is only 27 kilometers wide. That's 17 miles wide at its widest point. Deimos is even smaller, only 15 kilometers, 9 miles across at its widest point. And I say at its widest point because we can't even get a normal diameter. These moons are completely irregular. They're also more than 100 times smaller than our moon. And they're covered in craters, charcoal-hued dust, and rocks. So if we swapped our moon for the pocket-sized Phobos and Deimos, boop, paint it black. There'd hardly be anything in the night sky at all. Our new moons would basically look like bright-ish stars, or satellites zipping around in the sky. You wouldn't be able to pick them out of the constellations. Nighttime would be pitch black. Moonlight, as you know it, would disappear, which would wreak havoc on our nocturnal species across the globe. Good news for astronomers, but for everyone else, swapping out the moon with Phobos and Deimos would be a complete disaster. With hardly any comparable mass, well, the tides would almost be entirely driven by the sun. As oceanic tides drop dramatically, marine life would be so heavily affected that you could actually see the collapse of coastal ecosystems. This would change wind, waves, and global heat regulation. And worse, over millions of years, Earth would start to wobble wildly. Say that 10 times fast. Earth would start to wobble wildly. This means unpredictable seasons, ice ages, and droughts. Imagine the North Pole winding up at the equator for 50,000 years. Even more, and this one is wild, it could lead to the end of life on Earth as we know it, or at least an extinction level event. Phobos is slowly falling into Mars. It gets about 2 meters closer to Mars every century. That's 6 feet closer. In about 50 million years, it's either going to break up and shatter into a very small version of Saturn-like rings around the red planet, or it's going to crash directly into it. So, if Phobos is our new moon, well, you'd be looking at a 27-kilometer wide moon asteroid plowing into us in slow motion. That could be twice as big as the asteroid that wiped out the dinosaurs. So, yeah, extinction. Gotta say, I prefer our current moon to these guys. Okay, next up, the final moon of this swapping list, Enceladus. Enceladus is a frozen ice ball spinning around the far rings of Saturn. But it's got something cooking under the hood. It's not just riding along on the rings, it's actively contributing to the creation of Saturn's outer E-ring. Yeah, Enceladus is spraying icy water particles and gas into space. What does that mean for you once we swap our moon for Saturn's? Well, Enceladus is covered in fresh ice particles and snow, making it the whitest, most reflective surface in the solar system. So even though it's relatively small compared to our moon, it's still going to shine brilliantly. Nights would be dimmer, but nowhere near as dark as with the miniature moons of Mars. The problem with Enceladus, like any smaller moon we tag in, is that its mass is too small to create the same tidal forces that we're used to on Earth. You got it. So losing our moon and replacing it with Enceladus would essentially recreate the Phobos and Deimos disaster. Cue dramatic drops in oceanic tides, coastal catastrophes, and wild climate uncertainty. And eventually, unstable planet tilting. But at least you'd still be able to see at night. Though it wouldn't take long before all that ice started to sublimate and maybe melt. Enceladus's ice shell isn't nearly as thick as some of the bigger moons like Europa, so soon you could see oceans of water on our new moon. Hey, if it means we get another shot to see if life exists anywhere else in the solar system, I'm in. That's pretty cool. In short, swapping our moon with other moons is a neat idea, but if the moons are too big or too small, they'd cause catastrophic damage to our fragile coastlines and most of the planet. So while I'd love a chance to check out all the volcanoes from the moons of Neptune and Jupiter, I think I'll stick to our good old moon. After all, this is the closest place in the solar system you can deliver a burger to.
There are hundreds of billions of alien worlds in the Milky Way galaxy. And scientists have already discovered and confirmed over 5,000 of them.
They call these worlds exoplanets. Some of them are really small, like Kepler 37b. This tiny planet is even smaller than Mercury, the smallest planet in our solar system. Kepler 37 is just slightly larger than our own moon. It could easily replace our cosmic companion in the night sky. Only it's pretty far from us. This tiny space rock is located 208 light years from Earth, where it orbits a star that's a bit smaller and cooler than our sun.
Small rocky worlds like Kepler 37b are a pretty rare find. Because they're so tiny, they're more difficult to spot, but scientists have still managed to confirm about 200 of these worlds. Most of them are many, many times closer to their stars than our planet is to the Sun, and Kepler 62c is no exception. This Mars-sized exoplanet orbits its star roughly 4 times closer than Mercury orbits our Sun. It only takes a little over 12 Earth days to make a full orbit. Kepler 62c must be scorching hot and extremely volcanic. Definitely not the kind of place you'd want to visit. And neither is this exoplanet. KOI 55b. Scientists think this planet used to be the size of Jupiter, but then its sun exploded into a red giant and swallowed the planet whole. No surprise there, KOI 55b is incredibly close to its star. So close that it takes this hellish world less than 5 hours to make one orbit. And KOI 55b is evaporating so much that it will soon disappear from its planetary system. It's not alone. Many of these planets have their atmospheres torn away by their host stars. Some 41 light years from Earth, there's a super-Earth that used to be a mini Neptune. GJ 1132b might have had a thick hydrogen atmosphere in the past, but its young hot star stripped it away, leaving only a rocky core behind.
When its star stripped away its original atmosphere, some of the gases were absorbed into the planet's mantle, and now, through this planet's volcanism, they're released back. GJ 1132b could have become a potentially habitable world, but it's 26 times closer to its star than Mercury is to the Sun. No chances for life on this super-Earth.
But life might be possible on these slightly larger super-Earths. Scientists have found many of these worlds orbiting in their sun-like stars' habitable zones. And that's good news. Now, we'd have to go and explore more of these planets up close to find out what their atmospheres are like. This one seems intriguing. Kepler 452b is 1.6 times the size of Earth, and it's about 6 billion years old. Earth is a youngster compared to this world. Our planet is only 4.5 billion years old. Okay, now I know this is your favorite exoplanet, Kepler 22b. And I like it too. This super-Earth might be covered in a super-ocean. It sits comfortably in its star's habitable zone and has a huge potential for life.
The only problem is that it's big. Kepler 22b is 2.4 times larger than Earth and about 9 times more massive. If Kepler 22b was the size of Earth, it would have an average surface temperature of about 16 degrees Celsius. But because it's a lot bigger than Earth, it could be a rocky planet, a water world, or even a gaseous planet like Neptune.
And speaking of gaseous planets, at this size, exoplanets stop being super-Earths and become gas giants. More than half of all exoplanets we've discovered are either Neptune-like ice giants or gas giants like Jupiter. Many of them orbit a little too close to their host stars, and they pay a high price for that proximity. For one, they're incredibly hot, and sometimes their host star rips their atmosphere away. Kinda like what GJ 1132b went through. But among them, there are some cold planets too.
Oof! This is Kepler 16b. It's not quite as large as Jupiter, but the cool thing about it is that it orbits not one, but 2 stars. Only you wouldn't be able to see those stars because you wouldn't be able to stand on its surface. You see, Kepler 16b is a Saturn-sized gas giant. It might have some rocky elements inside it, but its 2 host stars are much cooler than our Sun, making Kepler 16b a frigid, lifeless world. Speaking of lifeless worlds, well, that might be what Earth becomes if we don't work to stop climate change. You've seen the hundreds of wildfires spreading across Canada. Well, this is due to climate change making the world hotter and drier. This toxic air made its way to New York, Toronto, Detroit, and Chicago, resulting in some of the worst air quality in the world. California is trying to prevent wildfires by purposefully burning thousands of acres a year. This is in order to reduce vegetation that could fuel a catastrophic wildfire. And this is just one example of what we need to do to help with climate change. Check to see what your local and federal governments are doing to help, because we only have one Earth and we don't want it to turn into one of these uninhabitable exoplanets.
Okay, now on to the worlds that are bigger than Jupiter. This delicious exoplanet has the density of a marshmallow. TOI 3757b is slightly larger than Jupiter, but it's not nearly as massive. But there are always bigger and badder planets out there, like Kepler 7b.
This one is interesting. Kepler 7b is larger than Jupiter, but it has half of Jupiter's mass. This means the planet is like a super light cloud, a scorching hot super light cloud. Kepler 7b is a hot Jupiter planet. It's 12 times hotter than the king of the solar system.
Still, Kepler 7b is not the hottest or the weirdest of the exoplanets. Some of these gas giants are so unimaginably hot that they tear molecules apart. Yeah, and some planets are just doomed. 1,400 light years away from Earth, a star slightly bigger and hotter than our Sun is devouring its planet.
This planet is called WASP-12b. It's almost double the size of Jupiter, but it's not going to last very long as far as planetary lives go. WASP-12b is so close to its star that it takes just over 1 Earth day to complete its orbit. Its own star is actually eating the planet's atmosphere, making it stretch into the shape of this egg. 10 million years from now, WASP-12b will be gone.
And some exoplanets are unimaginably huge. The biggest one of them is almost 7 times larger than Jupiter.
HD 100546b isn't just 7 times larger than Jupiter, it's also 750 times more massive. HD orbits its star 10 times further away than Jupiter orbits the Sun. That's pretty far, and it makes scientists wonder how this gigantic exoplanet formed so far away from its star.
There's no doubt that some exoplanets out there look promising for finding life. We've found quite a lot of them orbiting in the habitable zone of their stars. In fact, some of these worlds might even be better for life than Earth. Trees are falling, ecosystems are collapsing, and our infrastructure is crumbling. Crops are failing, and water is scarce. Earth is becoming a dead planet. On the plus side, there's never been a better time to buy property. But who can think about real estate when they can't leave their own home, let alone get out of bed, let alone breathe? This is What If, and here's what would happen if the Earth was as big as the Sun. Everyone knows the Sun is big. I mean, look at it. And that's just how big it looks from about 150 million kilometers away. Just imagine what it would look like if you were standing next to it. Never mind. The Sun accounts for 98% of the mass of our entire solar system. And compared to the densest planet, which is our very own planet Earth, the Sun is more than 1,000,000 times more massive. In fact, it would take roughly 1,300,000 planet Earths to fill the entire Sun. But what if it only took one? Earth would be a very different place if it were the same size as the Sun. Just imagine our whole planet's topography being stretched out. Continents would expand, providing much-needed relief in places where overpopulation inhibits the quality of life. And owning a nice plot of land might actually be more affordable than it is on today's planet Earth. But now we'd also have to consider that every body of water on our planet would have more area to cover. This means that lakes, rivers, and even the oceans would be shallower, making them more susceptible to evaporation and potentially drying out. Marine life would undoubtedly suffer since shallower water would gain more heat from the sun, jeopardizing sea creatures that need colder water to survive. With other smaller water sources beginning to dry up, wildlife on land might have to relocate or travel much farther for fresh water, which would also put them at risk. Us humans would be in an equally precarious position. Not only would we probably start fighting over the limited fresh water that's available, our food crop yields would also start shrinking. Food crops need a certain amount of soil to grow in and to absorb the nutrients they need.
If our world was as big as the sun, then, like the water, our soil would have to be spread out to cover a much larger space. Less soil would mean less food, while the demand for food would stay the same. There's also another issue that we haven't considered, which, when we factor it in, makes life on Earth pretty much impossible. Earth being the same size as the sun is hard enough to imagine, but when you consider a sun-sized Earth having the same mass as the sun, it doesn't only jeopardize our survival, it disrupts our entire solar system. Think about it. With the Earth as big as the sun, you'd pretty much lose the moon either way. But if a planet has more mass, it will also have a stronger gravitational pull. In this case, gravity on Earth would be 28 times as strong as it is now. We'll get to how this affects you in a moment, but first, let's look at the bigger picture. The reason why our solar system moves the way it does now is because the sun's mass is so great. Its gravitational pull forces other planets into its orbit. The sun currently has 98% of the mass in our entire solar system, but now the sun and the Earth would each have 49% of the mass in our solar system. Would this result in some sort of binary system in which the sun and the Earth orbited each other? How would this new rivalry affect the orbits of the other planets in our solar system? And would a significantly higher gravitational pull mean that Earth would get hit by a lot more asteroids? Well, there'd be a lot more to worry about than just asteroids. Our satellites would also probably crash down to Earth, while buildings and bridges would crumble and collapse under the increased gravitational pressure. Only thick trees that were low to the ground would remain standing, but it's unlikely that much else could shoulder the added weight. You would be significantly heavier, and you probably wouldn't be able to walk anywhere. Think about it. If you weigh 50 kilograms on Earth right now, it would feel like you weighed 1,400 kilograms on a sun-sized Earth. The cruel twist is that as gravity increases, time would slow down. So you might be able to live longer, but it would probably be a long life spent lying in bed with aches and pains. Luckily, we can wake up from this nightmare because the Earth will never be as big as the sun. In fact, our planet is actually getting smaller. Our atmosphere leaks, and so we end up losing several hundred tons of mass to space every day. So take a nice deep breath and be glad it's that easy. It's not always a good idea to mess with proportions, and bigger definitely doesn't always mean better.
Imagine you were able to shrink the sun to the size of a basketball. At that point, the Earth would be reduced to the size of a sesame seed. That's how massive our star is. But what if this fiery ball of gas and plasma wasn't the biggest thing in our solar system? Would our planet still orbit the sun? Or would the sun rotate around the massive Earth? What would happen to our planetary neighbors? This is What If, and here's what would happen if the sun was smaller than the Earth. It would take the equivalent of 1.3 million Earths to fill up the volume of the sun. It's so big that it makes up over 99% of the mass of our entire solar system. It only looks small from Earth because it's 150 million kilometers away. If, hypothetically, the sun was smaller than the Earth would be uninhabitable, and the sun, well, this massive star may no longer be a star. In the universe, size matters, and so does distance. It just so happens that the Earth is close enough to the sun that it doesn't freeze over like Mars. It's also far enough away that it doesn't get scorched like Venus. We're fortunate to be in the sun's habitable zone. This means that the size of our planet, the size of the sun, and the distance between the two of us is what's made it possible for life to evolve here on Earth. What would happen if the sun was smaller than our planet? A star's mass determines its color and temperature. Bigger stars are hotter and bluer, while smaller ones are cooler and redder. The sun is a white star, not as big as a supergiant, and not as small as a red dwarf star. You might think that by making it smaller in size, it would just turn into a red dwarf with a smaller habitable zone, but that's not the case.
By definition, a star, whether it's a supergiant or a red dwarf, is only a star when there's thermonuclear fusion in its core. How small can stars get? Well, we haven't measured too many red dwarfs at this point, but the smallest one we came across has a mass of 10 Earths. That's very close to the theoretically necessary size of a star to sustain that fusion. Anything smaller than 10 Earths wouldn't be a star anymore, but rather a cold and dark stellar remnant. If, for any reason, the Sun shrank smaller than the Earth, this shrunken Sun wouldn't have the mass to create fusion and would burn out completely. Our solar system would lose its only star. Since the Sun is the source of gravity that keeps us all in orbit, all planets, the Earth included, would float away into space in search of another anchor. That's no happy ending for life on Earth. Let's try this again. This time, let's make the Earth bigger than the Sun, while the Sun's size remains the same. Earth's mass would be at least 333,000 times bigger than it is now. A planet that big would generate enough heat and pressure in its core to become a star itself. Of course, there would be no life left on this hot star, but here's a cool thing. Our solar system would have not just one, but two suns. It would become a binary star system, with two stars orbiting around each other and planets circling them both.
It's a small world after all, because today we're shrinking Earth to the size of Pluto. But if our planet was this tiny, how would it alter the atmosphere? Why would Earth get hotter? And how would gravity affect our water supply? This is What If, and here's what would happen if Earth was the size of Pluto. Pluto sits on the solar system's edge, just beyond Neptune's orbit. It was once considered a planet, but then in 2006, scientists demoted this celestial body to a dwarf planet. All because Pluto isn't big enough to gravitationally dominate in its own orbit. After all, this dwarf planet is only 2/3 the diameter of our moon. So if Earth was as tiny as Pluto, how would 8 billion people fit on it? Say goodbye to your personal elbow room. We would have to fit everyone into an area slightly bigger than Russia, 71% of which would be covered with oceans. But the good news is, this shrunken Earth would still have room for everyone. Just barely. You and every person on the planet would have about 1.5 tennis courts to yourselves. The problem is, that doesn't take into account the space we need for hospitals, airports, and roads. Once we build those, things would start getting cramped. Add to that all the uninhabitable areas like deserts and mountains, and you won't have enough room to comfortably fit everyone. But if you're looking for a quick escape, it would be easy for you to make a break for it. One jump could catapult you almost 7.6 meters into the air. And that leap would last for almost 10 seconds, giving you a spectacular view of the horizon. You could also run faster since there would be less friction. But watch out for slick surfaces. They could send you flying long distances because there wouldn't be enough gravity to keep you in place. And refrain from overexerting yourself with all this running. On this dwarf planet, the air pressure would also be small. So no matter where you're at, it would feel like standing on a mountaintop 5,000 meters high. Yeah, with less oxygen to breathe, you would be constantly gasping for air. If you're lucky, this high-altitude sickness will leave you lightheaded, but if you're unlucky, it could kill you. But even that wouldn't be the worst-case scenario if the Milky Way always had a mini Earth. Technically, the lack of gravity would make Earth uninhabitable. A study out of Harvard from 2019 found that a planet needs a mass of at least 2.7% of the Earth to keep water on the surface. If Earth had formed to be the size of Pluto 4.5 billion years ago, it would never have its mighty oceans. Now, how would this affect the moon? Well, Pluto's largest moon, Charon, doesn't orbit the dwarf planet. Instead, the two bodies are tidally locked with the same sides always facing each other. Our dwarf Earth would be forever facing the moon in the same position, locked in place by a common center of mass caused by our competing gravitational pulls. But all of this would be the least of our problems. If Earth was this small, its inner core would be much cooler. Now, that might sound good at first. Earthquakes would stop because there wouldn't be shifting tectonic plates anymore. Volcanoes would become harmless mountains. But unfortunately, Earth wouldn't have a protective magnetic field without the hot molten core. With this gone, the radiation from the sun would fry our planet. Now, what if Earth wasn't formed to be the size of Pluto? What if instead it suddenly shrunk? Well, then our planet would keep its mass, but that would make the surface gravity 30 times stronger than what it is now. With intense training, the human body can survive on a planet with 4 times the Earth's gravity, but a planet with 10 times the gravity of Earth? That would break your bones. If you weighed 75 kilograms before, now you would weigh around 2,300 kilograms. Every move you make would take serious muscle power, and you may not have it in you, no matter how hard you try. An instantaneous dwarf Earth would cause mass devastation. It could destroy everything we love about this planet and leave humanity hanging on for dear life.
If suddenly you started to shrink in size, how long would it be until you became as small as a particle of dust? Why would things look different to your eyes? And why should you stay away from these grabby things? Today, you'll be scaling down by 1 centimeter every second, from human-sized all the way down to the size of a subatomic particle. Your shrinking adventure would begin suddenly. You'd start at an average adult size. Your mass, your voice, and your grip strength would all feel normal. Whoa, but after just 10 seconds, you'd drop 10 centimeters in height. That's about 4 inches. The fun part is, your weight would be falling faster than your muscle force, so you'd feel deceptively springy. Now, after 20 seconds, you'd be down another 10 centimeters. You'd be breathing just a little faster and shallower. That's because your lungs would start shrinking too. All of these changes would be pretty subtle, so you might not realize what was happening at first. But now, a whole minute has gone by and you've shrunk to the size of a child. Yeah, you'd be 60 centimeters or 24 inches shorter than where you started from. That you would notice. At this point, you'd have lost 1/3 of your mass. You may feel lighter and more agile, but you'd also be losing heat fast, so even a small draft would be pretty chilly to you. As you gasp, wondering what's happening to you, you'll hear a tiny, high-pitched voice. Oh, that's you. Your voice will get higher because your vocal cords will be shrinking down with you. And so would your other organs.
No!
Keeping warmer would be harder, and you'd be inhaling far fewer air molecules. Metabolically, you'd be turning into a small mammal. Now, if your clothes didn't shrink at the same rate as you, which they wouldn't, they'd become a hazard. Your sleeves would swallow your hands and your pants would fall down. Soon, you'd be running around this big room naked. But for the sake of our viewers, we're going to keep this story PG and make your clothes shrink along with you.
In just 90 seconds, you'd be less than 1 meter in height. That's 3'4", like a 4-year-old. The furniture would tower above you. Your field of view would be so much lower that you'd see things you haven't noticed since you were a kid. After 2 minutes, you'd have lost 120 centimeters. That's 4 feet. The pitch of your voice would rise higher, and you wouldn't just look like a child, you'd sound like one too. And here's a new superpower. Your ear canal resonance would shift up, so you'd hear higher frequencies that you couldn't catch as an adult. Hopefully your survival instinct kicks in fast, because you'd be light enough now that a moderate gust of wind could knock you over. If a house cat wandered into the room, it would look more like a tiger. It would pose a real danger. 2.5 minutes into this scenario, you'd only be 30 centimeters tall. That's 1 foot. At this point, you'd be the same size as a domestic cat, only you wouldn't feel as strong. The good news is because you shed all that weight, even jumping down from a tabletop wouldn't hurt you. Pretty soon, things will get way more interesting and you'll enter a world you've never seen before. Yeah, just over 8 minutes into this journey, you'll be in a world of proteins and molecules. But for now, after 170 seconds of shrinking, you'd only be 10 centimeters tall. That's 4 inches, twice as big as a mouse. Insects would be scary. A cockroach would seem as large as a dog relative to you. And you wouldn't recognize the environment around you. Every speck of dust on the floor would be like a rock. And what looked like ordinary dust when viewed from your regular height might reveal itself as a colony of microscopic particles and tiny creatures. Okay, after 3 minutes of your downsizing journey, you'd be roughly 1 centimeter or 3/8 of an inch tall. Now, you'd be the same size as a large insect. And to anyone regular sized, you've basically become a bug. Try not to get yourself squished. At this size, grooves in the floorboards would look like trenches, and carpet fibers would rise like dense bamboo. The air would feel different, almost syrupy. Now, it's not because the air down there is different, it's because now you'd be so small that you'd feel air resistance pushing against your every step. Right about now, you'd be entering the microscopic world. This ride is about to get wild. After you passed the 3-minute mark, you'd be a mere 1 millimeter in height. That's 1/25 of an inch. You'd be the same height as a micro SD card. Now, you'd see dust mites moving like stubby spined bulldozers through the carpet forest. They'd be half your current size. And other insects would seem like giants. An ant would tower above you 5 times your size. You'd be so tiny and frail that even your own breath would shove you backwards. You could slip into a keyhole, disappear beneath a floorboard seam, or, just get inhaled like a speck of dust. Soon, you'd slip below the threshold of what your eyes can see as you're about to enter the realm of microbes and cells. Okay, you've been shrinking for 4 minutes, and now you'd be about as tall as a strand of human hair is wide. The world wouldn't look the same to you from the height of 100 micrometers, and the world wouldn't even see you, not without a microscope. Oh, look, that living jelly puddle in front of you is an amoeba. An amoeba is a tiny living organism made of just one single cell. Scientists call it a unicellular eukaryote. Now, it might just have one cell, but it's a complex cell with a nucleus and organelles. This tiny creature eats its food by hugging and absorbing it. The largest amoeba are about the same size as you are now, so watch out. Do not let it hug you. And definitely don't get too close to paramecium. These guys, just like amoebas, are single-celled, only now they'd be 3 times your size.
Paramecia are super fast too. They can swim at 2 millimeters per second, which at your scale would feel astonishingly like super speed. Lucky for you, they can only live in water, so just try to avoid the water drops. I mean, that's good advice for you at this point anyway, considering your size. This microscopic world would be so new and exciting. Like that large bear-looking creature, that's a tardigrade, or literally a microscopic water bear. These are awesome. Not only do they look very plump and friendly, but they're also some of the most resilient organisms on the planet. Tardigrades can survive anything like freezing temperatures, crushing pressures, and even the vacuum of space. But even though they look friendly, you better get out of their way now. Not only would you be tiny and invisible to the naked eye, but your own eyes wouldn't see things the same anymore. Right now, you'd be about the same size as the wavelength of visible light. For you, everything would look like a blurry haze, and all the colors would start to fade. In this new microscopic world, you'd even walk differently. The gravity would feel weaker, and you could walk up a water droplet. The capillary forces would support your tiny weight so you wouldn't fall. Yeah, walking on water is a thing when you're this tiny. 5 minutes after the start of your shrinking journey, you'd see a forest of mold spores and fungal hyphae around you. And you'd start seeing some of the largest bacteria too. But it's time to shrink even more. After 6 minutes of shrinking, you'd be as small as a human cell. Those white blobs in front of you now, well, those would be your white blood cells. And the red ones? You guessed it, red blood cells. Being inside a human blood vessel would be like surfing on blood cells. Watch out for those white cells. Oof. Those bumpy spheres are covered with grabby, arm-like receptors, ready to capture and engulf bacteria at any moment. Now, if you were on the surface of human skin, the pores would look like giant craters on an alien planet. You'd start seeing organelles inside cells. These little structures would be the size of a pumpkin back when you were regular sized. At this scale, your nervous cells, or neurons, would look like giant trees branching axons and dendrites instead of tree branches. Once you've shrunk down to the size of half a micrometer, that's bigger than half a micrometer, you could start wandering around inside a human cell, exploring the vast, crowded warehouse of organelles and the cell's nucleus. But let's keep shrinking. Things are about to get submicroscopic. After 9 long minutes, you'd be just one nanometer tall. That's 1/1000th of a meter. Now, you'd be on the same scale as small molecules and even large atoms. This little guy is a single molecule of carbon, only 3 times smaller than you. You yourself would be just 5 to 10 atoms in height, but you wouldn't really see anything down here with your eyes. That's because now you'd be smaller than the shortest wavelengths of visible light. But you can touch the things around you. Atoms would give you a fuzzy resistance kind of feeling. That would be the electrons creating electromagnetic forces inside an atom. The atomic nucleus, that's the core of an atom, would still be far smaller. That tiny thing is only 1 femtometer in diameter. Yeah, you ever heard of that measurement? I haven't. That's 1/1000th of the size that I am right now. Okay, after 10 minutes of continuous shrinking, you'd finally be the same size as an atom. This is around the time when the laws of physics get out of hand.
You're now in the quantum world. The very concept of having a consistent shape or seeing in a usual way would break down. Not that you could see anything anyway. Everything around you would be vibrating. An atom next to you might suddenly swap places with another. That's called a quantum jump. Radiation at this scale is deadly for larger creatures, but to you, it's just part of the environment. A stray X-ray photon might blast through, larger than you are, maybe carrying you with it like a leaf in a hurricane. The subatomic world of protons, neutrons, and quarks is beyond tiny. At this scale, you would no longer be a separate being. You'd be part of the atomic lattice. You might even bind into a molecule. That would be the end of your journey. You yourself become a building block, an atom that makes up a molecule that makes up something bigger, like a regular-sized you. Well, things don't always have to get smaller. Maybe next time you'll grow bigger, become the size of a dinosaur. But that's a story for another What If.